Hi guys, we are the grade 12 students from CNHS.
We're about to teach you some chemistry sample problems.
This chemistry video tutorial will help you how to calculate the mole fraction and the vapor pressure of a solution containing two volatile substances. So,
We hope that you can learn something from this. Let's go! In this video, we're going to use Raoult's law to calculate the vapor pressure of two volatile solutions mixed together. Note that in chemistry, the word volatile refers to a substance that is readily vaporizable at low temperature. A volatile substance has a high vapor pressure at a given temperature compared with a non-volatile compound. So how can we calculate the vapor pressure of a volatile solutions? So let's go ahead and work on it.
so we have a sample problem. A 30.0 milliliter of hexane C6H14 is mixed with 45.0 milliliter of benzene C6H6. The densities of hexane and benzene are 0.66 gram per milliliter and 0.87 gram per milliliter respectively. The vapor pressure of hexane and benzene at 60 degrees Celsius are 573 torr and 391 torr respectively. So we have a required calculation. A. What is the mole fraction of each substance in the solution? B. What is the vapor pressure of the solution?
So we have to write down the given. We have 30.0 ml of C6H14, which is the hexane, and a 45 ml of C6H6, which is the benzene. And the density of hexane is 0.66 grams per milliliters. And the density of benzene, which is the 0.87 grams milliliters. And we have the vapor pressure of benzene, which is 391 torr at 60 degrees Celsius, and the vapor pressure of hexane, which is the 573 torr at 60 degrees Celsius. And we have to write the required calculation. We have the mole fraction of hexane, the mole fraction of benzene, and the vapor pressure of the solution. So we have 30.0 milliliters of hexane and it's mixed with 45.0 milliliters of benzene. Now we're given the densities of these two substances and we're also given the vapor pressure of those two substances at 60 degrees Celsius. So the first thing that we need to do is to calculate the mole fraction of each substance in the solution. Now, we first need to determine the number of moles of each solution in order to be able to calculate the mole fraction of the components. So let's start with hexane.
We have 30.0 milliliters of hexane at C6H14, and we can convert milliliters into grams using the given density of hexane, which is 0.66 grams per milliliters. So now we have the mass of hexane in grams. So now we need to convert that to moles. So we get to find the molar mass of hexane C6H14. So we have 6 carbon atoms and 14 hydrogen atoms. From the periodic table, the atomic masses of the carbon and hydrogen atoms in hexane are carbon 12 and hydrogen is 1. So that's going to be 6 times 12 plus 14 times 1. Molar mass of hexane is 86 grams per mole, and put that in the next fraction. So 1 mole of C6H14 has 86 grams. So now cancel the unit grams and then calculate. So 30 multiplied by 0.66 divided by 86, and so this is going to be 0.23 moles of hexane. Well, let's do the same thing for the other substance, and that is for benzene. So just like before, we could cancel the milliliters using the given density of benzene, which is 0.87. Now we already have the mass of benzene. So we get to find the molar mass of benzene for the next fraction. So we have 6 carbon atoms and 6 hydrogen atoms. From the periodic table, the atomic masses of the carbon and hydrogen atoms in benzene are carbon is 12 and hydrogen is 1. So that's going to be 6 times 12 plus 6 times 1. And now the molar mass of benzene is 78 grams per mole. And put that in the next fraction. Cancel the unit grams, then calculate. 45 multiplied by 0.87 divided by 78. And so, this is going to be 0.50 moles of benzene.
So now we can calculate the mole fraction of each substance. So let's start with the mole fraction of benzene. The numerator will be the moles of benzene. Divided by the sum moles of hexane and benzene. So it's 0.33 divided by the moles of hexane plus moles of benzene, which result to the total moles of 0.73. So 0.33 divided by 0.73 is equal to 0.32. And so that will give us the mole fraction of hexane.
So, let's proceed to the mole fraction of the other substances, which is benzene. Since there are only 2 substances in a solution and the total fraction is equal to 1, we can calculate using this formula. Mole fraction of benzene is equal to 1 minus mole fraction of hexane. Which is 1 minus 0.32 and that will give us to 0.68 mole fraction of benzene. This is the required mole fraction of each substance.
So let's move on to the calculation of vapor pressure of the solution. We can find the total vapor pressure by plugging the values into the equation. Vapor pressure is expressed by Raoult's law, which illustrates as this. Where P solution is the vapor pressure of the solution, X solvent is the mole fraction of the solvent, P degree solvent is the vapor pressure of the pure solvent or the standard vapor pressure.
Notice that in this problem we have 2 volatile substances that are mixed, so each pressure component of the mixed solution is added together to find the total vapor pressure. So we go to this equation.
So this equation equates to total vapor pressure is equal to the mole fraction of hexane times the standard vapor pressure of hexane, which is also already given in the problem, plus the mole fraction of benzene times the standard vapor pressure of benzene, which is already given in the problem. So mole fraction of hexane 0.32 is multiplied to its standard vapor pressure 573 torr plus 0.68 mole fraction of benzene, and that is multiplied to its standard vapor pressure, which is 391 torr. So we're gonna have 0.32 multiplied by 573 torr, which resulted 183.36 plus 0.68 multiplied by 391 torr, so which result to 265.88 torr. So next, we're gonna add up these two values, which is 183.36 torr and 265.88 torr. So that's gonna be 449.24 torr vapor pressure solution.